If you've even, dipped a toe into the world of large language models, it can
Yeah.
feel like, well, like a massive, overwhelming ocean.
It really can.
So much information, all these tools, just an endless stream of buzzwords. How do you possibly cut through that noise and figure out how to actually use these powerful technologies without getting totally swamped?
Yeah, it's a very real challenge. Everyone wants to harness LLMs, but the path, well, it often feels like trying to navigate a dense jungle without a map, especially when you start thinking about cost and risk.
A crucial point. So our mission today really is to give you that map. This deep dive is kind of your shortcut to understanding what we're calling the open source path to LLM excellence.
Hmm.
We've pulled out the most important nuggets from a really comprehensive guide on building and deploying LLMs. And it's tailored specifically for different organization sizes.
And the focus is really on cost efficiency, yeah.
Yeah,
Reducing risk and helping you build that vital internal expertise.
exactly. Our insights, they're drawn directly from this detailed Stepwise guide and its associated architectural recommendations.
It really does lay out a practical, actionable roadmap, cuts through a lot of the theory.
And that's why this deep dive is so relevant for you. It doesn't matter if you're a small team looking to get started affordably, or maybe a medium-sized organization trying to balance scalability and customization.
Or even an enterprise aiming for that full control and governance.
Right. It's about making LLM adoption feel tangible,
Yeah.
achievable for everyone.
What's really fascinating here is that despite the huge differences in scale and resources, every single organization navigates this fundamental LLM lifecycle.
Ah, okay. The core process.
Exactly. It's a 10-step process. Basically, the framework for how LLMs come to life starts with raw data, goes all the way to user interaction. Understanding this lifecycle is absolutely crucial, whatever your size.
Okay, so let's walk through these steps then. What's the absolute first thing? Where do you kick things off?
Well, step one is data collection, always. This is about gathering all those diverse data sets, text, code, whatever you need.
And what are we talking about here? Parameters.
You're looking at the type of data, structured, unstructured. Volume is huge. We're talking terabytes, maybe even petabytes.
Wow.
Diversity is also key, different domains, languages, and of course, the sources. Web scraping, licensed data, your own internal stuff.
It's interesting how the big players approach this differently, right? Like OpenAI.
Yeah, OpenAI is known for its absolutely massive, deeply curated data sets, but maybe less transparency there.
All right,
Well,
versus.
contrast that with Meta's Llama series. They tend to use more open data sets, focus on scalable collection, and then you have Mistral taking a different tack entirely.
What's their approach?
They really zero in on lean, high-quality data sets. It highlights this core trade-off, scale and curation like OpenAI, or flexibility and transparency like Meta and Mistral. For many, that control over bias and privacy with open data is huge.
Makes sense. And tools for this, what are people using?
Standard stuff, mostly. Web scrapers, APIs, Google dataset search is handy. And of course, Hugging Face datasets are a massive resource.
Okay, so you've gathered all this raw data. It's probably a mess though, right?
Usually, yeah. That's where data preprocessing comes in. Step two,
Cleaning time.
pretty much. Cleaning, deduplication, filtering out sensitive content. It involves things like language normalization, removing junk tokens, and crucially, bias filtering. Got to refine the input.
Garbage in, garbage out, otherwise.
Exactly. This is where a lot of the heavy lifting happens for quality and safety.
How do the big names handle this part?
Well, OpenAI and Google, they invest heavily in proprietary preprocessing. Anthropic is particularly known for its really rigorous safety filters. They aim for safer outputs right from the start.
And Meta. Still open.
Yeah. Meta embraces a more transparent, community-driven filtering approach. The takeaway is that investing here significantly improves quality and safety, but it can be complex, resource-heavy too.
Tools for that.
Things like Spacey, NLTK are common. LangChain also has pre-processing pipelines that are useful.
Okay, data's collected, data's clean. How do we actually get it ready for the model to understand? That's tokenization, right? Step 3.
Spot on. Tokenization is breaking text into smaller units, subwords, or words. It's how the model understands and processes input efficiently.
So efficiency is key here.
Absolutely. Parameters matter, the type of tokenizer, like BPE, that's byte pair encoding unigram, word piece, vocabulary size too. It directly impacts how much text the model handles and how fast it trains.
And I bet the big companies have their own secret sauce here too.
Oh, for sure. OpenAI and Google emphasize highly optimized, efficient tokenizers. Anthropics are pretty similar to GPTs. Meta uses BPE-based ones, but they're open.
The benefit being?
You dramatically reduce input size, speed up training. That directly lowers costs. The challenge: sometimes segmentation errors if the tokenizer isn't quite right for the data.
Common tools?
Sentence pieces widely used. Hugging Face tokenizers are everywhere and often open source, which is great.
All right, then comes the really big one, step 4. Model training. This sounds computationally intense.
It is. This is where you use massive computational resources to actually build the LLMs. We're talking serious power, serious time.
What kind of decisions are made here?
Foundational design choices, like a decoder-only architecture, think GPT, great for generation. Or an encoder-decoder like T5, often used for translation. Then there's just the sheer scale, billions, even trillions of parameters.
Trillions.
Yep. Demands powerful hardware like GPUs or TPUs, which are Google's custom AI chips. And training can take weeks, even months.
This is where you really see the scale difference between players.
Precisely. OpenAI operates at that trillion parameter scale, incredibly expensive.
And others.
Anthropic focuses intensely on alignment during training safety, ethical behavior. Google leverages its TPUs for massive scalability, and Meta is pretty unique, releasing open weights with its Llama series.
That's been huge, hasn't it?
Absolutely democratized access. Anyone can download and run these powerful models. The strategic pro is getting these incredibly capable models. The con: extremely costly and time-consuming, out of reach for most to train from scratch.
Tools for training.
PyTorch is dominant. Deep speed for distributed training. Hugging Face Trainer is popular. And Google TPUs, if you have access.
Okay, after all that intense training, you need to know if it actually worked and if it's safe. Step 5. Model validation.
Right. Model validation means testing. Testing on diverse data sets for performance, bias, and, really importantly, hallucination.
Hallucination meaning making things up.
Essentially, yes. So key parameters are your evaluation data sets, metrics like perplexity, BLEU for language tasks, accuracy, plus robustness and safety checks. It's rigorous testing before you let it loose.
How do the leaders approach this alignment part?
OpenAI and Anthropic are known for strong alignment testing, making sure models behave, don't produce harmful stuff. Google focuses on extensive multilingual validation.
Meta, still open.
Yeah. Embracing their open philosophy, they rely heavily on open benchmarking. The community scrutinizes performance, finds weak spots.
Benefit seems clear: reliability, trust.
Definitely. The challenge, though, is potential evaluation bias if your test sets aren't truly representative. Tools like Eleuther AI's evaluation harness, LLM from Stanford, they're invaluable here.
Sometimes, though, a general model isn't quite specific enough. You need to customize it. What's fine-tuning? Step 6.
Exactly. Fine-tuning is optional but incredibly powerful. You adapt a pre-trained LLM for a specific domain or task.
How does that work?
You have different methods: full fine-tuning, which retrains everything, or more efficient techniques like LoRa or PEFT, parameter efficient fine-tuning.
Parameter efficient, meaning less compute.
Exactly. Lets you adapt large models without needing nearly as much data or compute power as full retraining. The data needed is much smaller. Safety tuning is also often part of this.
So if you want your LLM to be an expert in, I don't know, legal contracts or medical notes,
This is how you do it. Specialize it.
how do the different players offer this capability?
Meta really stands out. They offer fully open fine-tuning with their models. Huge advantage for flexibility and control.
Unlike
OpenAI, which offers fine-tuning mostly via its APIs, often with limits on which models you can tune, Anthropic is less open about direct fine-tuning. Google supports it through Vertex AI.
the pro seems obvious: better performance on your specific tasks. Cons.
Well, it's still additional computational cost, and there's a risk of overfitting, making the model too specific if you're not careful. Tools like Hugging Face, PEFT library, or OpenAI's API are what you'd use.
Okay, models trained, maybe fine-tuned. Now you need to actually get it out there. Step 7, model deployment.
Right. Serving the model for production use. Deployment type is critical here.
Like how?
Is it API-based? Running on your own servers, on-premise, in the cloud, even on edge devices like phones?
And performance matters here, I assume. Latency.
Yep, latency, how quick the response is, scalability, how it handles many users, and cost per inference, what it costs each time the model generates something.
This feels like where the rubber meets the road for practical use. How do the competitors manage deployment?
OpenAI and Anthropic are primarily API-based. Controlled, managed deployments. Google supports both on-prem and cloud. Meta, though, is super flexible.
How so?
They allow local deployment of their open models. That's a huge differentiator. Gives users way more control over data, privacy, cost.
So flexibility is the benefit. Challenges.
Latency and cost can vary wildly depending on the model size and how you deploy it. Tools like AWS SageMaker, Google Vertex AI, Docker for packaging, Kubernetes for managing those packages, they're essential here.
Now, how do you actually talk to these models effectively? Get the results you want. Step 8, prompt engineering.
This is truly an art form. It's about crafting the prompts to guide the model's behavior.
More than just asking a question.
Oh, yeah. Using prompt templates, techniques like few-shot learning, giving examples, or zero-shot, no examples, chain of thought, guiding its reasoning, understanding the context, window size, how much text it can see.
It's like learning a new language to communicate with the AI.
It really is. OpenAI has extensive documentation. Anthropic emphasizes safer prompting, getting better refusals for bad requests, which is important.
Right. Reliability.
Google supports longer prompts for more complex instructions. And Meta, with its open models, has this vibrant open-source prompting community sharing techniques.
Main benefit. Better results.
Targeted, high-quality results. The con. It can definitely take a lot of trial and error to get prompts just right. Tools like LangChain, Llama Index, various prompt libraries help manage this.
Okay, prompt sent, model thinks, then step 9, inference, the actual interaction.
Inference is simply the model generating output based on the prompt. Key things here are context length can range from maybe 4,000 tokens up to an incredible 1 million now.
1 million tokens, that's a lot of text.
It's huge. Response time, quality of reasoning, cost per token, these all matter at inference time. This is where you see the model's capabilities live.
And this is where we see those cutting-edge features, like Google Gemini 1.5 handling those massive contexts.
Exactly. Or Meta's Llama 3 enabling free local inference on your own machine. OpenAI's GPT-4o is incredibly fast with strong reasoning. Anthropic's Claude 3 is known for safety and handling long contexts well.
Benefits seem clear: advanced reasoning, creativity. Downsides.
Cost and latency scale with model size. Bigger models cost more per interaction. Tools are typically the APIs themselves, OpenAI, Google Vertex AI, or local inference servers if you're self-hosting.
Finally, step 10. You can't just deploy and walk away, right? Monitoring and feedback.
Absolutely not. This is a continuous process, tracking model behavior in production.
Looking for what?
Drift detection is performance degrading. Our output's changing weirdly. User feedback loops are vital for catching real-world issues, setting up automated retraining triggers. This whole thing is part of MLOps machine learning operations.
So definitely not set it and forget it. How do the big players monitor?
OpenAI offers built-in monitoring via its API. Anthropic focuses heavily on safety monitoring. Google provides enterprise-grade solutions, often tied into their cloud platforms.
And Meta.
True to form, Meta allows for open-source, user-controlled monitoring, more transparency, more customization.
Benefit is obvious. Continuous improvement, stability, crucial.
Yep. The challenge. It requires dedicated monitoring frameworks and ongoing effort. Tools like Datadog, Prometheus, custom logging pipelines are common.
So that's the 10-step LLM lifecycle in a nutshell.
Okay.
But as you said, the real magic happens when you tailor this to your organization's size and maturity.
Right. And the guide we're looking at introduces 2 more crucial steps that organizations layer on top.
Which are?
Strategy and use case definition, figuring out what you actually want to do, and security and compliance. Plus, a much stronger overarching focus on continuous improvement.
Okay, so this is where the roadmap gets really practical. Different paths for different folks.
Exactly, based on resources, goals, needs.
Let's start small then. Small organizations. What does their LLM journey typically look like? Why that way?
For small orgs, the strategy is usually pretty focused. Maybe 1 or 2 core use cases, often leveraging off-the-shelf models. Think a basic internal chatbot for FAQs, maybe a summarization tool. For data, they'll mainly rely on public datasets, simple web scraping, perhaps some internal docs. Preprocessing is basic Python libraries like Pandas, Spacey.
So they're definitely not building models from scratch here, more like using existing tools?
Precisely. Model selection is primarily pre-trained API models. Think OpenAI, GPT-4o, Claude API. Usually no fine-tuning at this stage. Goal is rapid, cost-effective deployment.
And deployment itself.
Very cloud API-driven, often using low-code tools, maybe Zapier for simple API calls. Security. They mostly rely on the vendor's security certifications.
Okay, but what about the free options? How can small teams get started without spending much?
Oh, there are lots. Free brainstorming templates. Tons of public data on Hugging Face datasets. Python libraries for pre-processing are free. and powerful free open source models.
Which ones?
LemonMay 3.8b, Mistral 7b, Phi3, OpenChat, all excellent small models. And deployment can be done with easy tools like Gradio or locally using Docker, zero software cost.
Nice. Okay, moving up the ladder. Medium organizations. How does the picture change for them? What are the shifts?
Their strategy definitely broadens. They'll explore more use cases, start with APIs, but also begin experimenting with fine-tuning.
Getting their hands dirtier.
A bit, yeah. Data collection becomes a blend, public data plus their own proprietary internal data. Preprocessing gets more robust.
Tools.
Maybe Databricks, LangChain pipelines for more complex flows, Apache Spark if datasets are bigger, OpenRefine for cleaning.
So a mix of external APIs and maybe some internal model work, especially on sensitive data.
That's a good way to put it. For models, they'll mix APIs like OpenAI or Google Gemini, but also experiment with fine-tuning. Maybe using efficient methods like Lurai with Hugging Face PFT run locally.
And deployment scales up too.
Yep, cloud APIs plus potentially low-latency edge deployments using Docker and maybe fast API for serving. Security awareness also ramps up thinking about SOC 2 compliance, GDPR, vetting vendors more rigorously.
What about free options for this mid-sized group trying to stay lean?
Still plenty. Agile boards like Trello's free tier for managing projects, Kaggle datasets for more data variety, Spark Community Edition for pre-processing, open source tokenizers.
And model.
Larger open source models become viable. Llama 3.8b or even the 70b parameter version, Mixtral, Gemma from Google. They can even self-host the Hugging Face inference server for free local inference.
Okay, now for the big guns. Enterprise organizations. What's their roadmap look like, given their scale and complexity?
Right. For enterprises, the strategy involves multiple, often critical use cases across many departments. They'll blend vendor APIs with custom, often proprietary models.
Data gets serious here.
Very tightly governed enterprise data lakes, maybe partnerships for external data. Pre-processing moves to enterprise-grade ETL tools, extract, transform, load, think Informatica, Talend. Strong data governance, privacy controls are paramount. Custom tokenization might even come into play to optimize cost and latency.
So we're talking full-blown custom solutions, complete control over the entire pipeline.
That's often the goal, yeah. Model selection and training focus heavily on fine-tuned proprietary models, often running on-premise using open models like Llama as a base, but with custom fine-tuning using PEP or LoRa on large cloud clusters, AWS, Azure, GCP.
Deployment must be complex too.
Multi-cloud hybrid setups are common. Using Kubernetes for orchestration, platforms like Vertex AI or AWS Bedrock, plus on-prem clusters, often inside virtual private clouds, VPCs for tight security.
And monitoring. Full MLOps.
Absolutely. Full MLOps, versioning, CI/CD pipelines specifically for LLMs, automatic retraining loops, enterprise-grade monitoring with tools like Prometheus, OpenTelemetry.
And security must be absolutely central at this scale.
Non-negotiable. Data encryption everywhere. Comprehensive audit trails, sophisticated AI governance tools, maybe even private LLMs developed in-house, on-premise deployments, VPCs, encrypted storage using open source tools, all central to their strategy, complete control and compliance.
Even at this scale, do free options still play a role?
Yeah.
Can enterprises leverage open source?
Definitely. Internal teams can use open frameworks like CrispDM for project structure. They can leverage huge public datasets like C4, deploy open source Spark clusters for processing.
What about the models themselves?
Custom, fine-tuned versions of powerful open-source models are very common. Llama 370b, Mixtral 8x7b, Falcon 180b, MPT models. These are strong choices. And for deployment and ops, Kubernetes is free open source. Rayserve, Llama, CPP, VLLM offer free inference options. MLflow for tracking experiments, GitLab CI/CD for pipelines, all can be run open source at scale.
Okay, but let's zoom in on something really key here. This whole open source path. The core benefit feels like incredible cost efficiency and vendor flexibility. You really don't have to break the bank.
That's absolutely right. The availability of these robust, really performant open source models has just revolutionized the landscape. It's democratized access to powerful AI in a huge way.
Can you maybe give us some specific free model recommendations again, just to hammer home how accessible this is for each size?
Sure. For small organizations, definitely look at Mistral 7b, Alame 3.8b, Phi3 from Microsoft, OpenChat. Great starting points. Medium organizations can scale up to Llama 3.8b or 70b. The Mistral models, Mixtral, Gemma, more power, still free.
And enterprise.
For enterprises, the larger open models are excellent choices, often custom fine-tuned. Lemma 370B, Mixtral 8x7B, Falcon 180B, MPT models.
It's not just the models, though, is it? There's this whole ecosystem of free tools supporting the journey. What are some key categories and examples that really stand out?
Yeah, definitely. For data platforms, you can start simple, .local files, Squillet, then leverage Hugging Face datasets or Kaggle tons of free data.
Preprocessing.
Pandas, Spacey, NLTK standard Python libraries, all free. Apache Spark's open source version for bigger data. dbt Core for transformation. These help clean and prep your data without cost.
And getting the model out there for users. Deployment.
For deployment, you've got simple options like Gradio or Flask. Docker and FastAPI for more robust services. Hugging Face offers local inference options. For scaling, Kubernetes is the open source standard. RayServe, Llama CPPP, VLLM offer efficient inference serving.
What about vector stores? They seem critical for RAG retrieval augmented generation.
Yeah, RDAG is huge for pulling in external info. Free options for vector stores include Chroma, AISS from Meta, Weaviate's Community Edition, Milvus open source, plenty to choose from.
And keeping an eye on performance. Monitoring without a big bill.
You can start simple manual logs, maybe Streamlit dashboards, then scale to robust open source monitoring tools, Grafana, Prometheus, OpenTelemetry for collecting metrics, and MLflow for tracking experiments and models.
And managing prompts.
Right, prompt orchestration. Tools like LangChain, Llama Index, Haystack are largely open source.
Okay.
Prompt Layer has a free tier, excellent for building sophisticated prompting strategies.
And we should probably give a shout out to those broader free resources too.
Oh yeah. Hugging Face Hub is indispensable for free model downloads. Kaggle datasets datasets. And GitHub is just a treasure trove of free MLOps tools, inference code, training pipelines you can adapt.
Okay, so if we try and tie all of this together, what does this detailed roadmap really mean for you, the listener? What are the tangible advantages?
Well, it boils down to several key benefits, I think. First, strategic clarity. This guide gives you a step-by-step decision framework. Helps you define realistic LLM paths aligned with your actual business size and goals.
Right. And that connects directly to cost efficiency, which we've hit on a lot. It shows you how to leverage free and open source tools to avoid unnecessary spending. That's huge, especially for smaller or medium companies just starting out.
Then there's scalability. The roadmap offers this natural growth path. You can start with basic API usage, then move towards full-scale enterprise deployment as your needs evolve. It supports that long-term expansion.
Which also enables vendor flexibility. That seems critical.
It really is. It actively encourages using open source LLMs like Llama 3 or Mistral that reduces vendor lock-in, lets you self-host, gives you much more control over your destiny, so to speak.
And it means technical readiness, right? The guide lists appropriate tools, deployment strategies, monitoring approaches that are actually matched to your capability, makes it actionable.
Exactly. And critically, security awareness. It aligns security and compliance strategies to each org size. Promotes privacy-first thinking, which is vital if you're handling sensitive data.
Finally, maybe learning and innovation.
Yes. It enables faster experimentation. You can try out free models, deploy locally, let your teams build that internal LLM expertise without needing a massive upfront investment. Lowers the barrier to entry for innovation.
So bottom line, small teams can get started quickly, affordably. Medium orgs can balance scale and customization with powerful available tools. And enterprises.
Enterprises can get full control, customize, govern LLMs at scale, even leveraging self-hosted open source options. It truly provides a viable pathway for basically everyone.
It really demystifies the process, doesn't it? Gives that actionable step-by-step guidance.
I think so. Makes it feel less daunting.
Okay, so we've journeyed through the whole LLM lifecycle. We've looked at how it gets tailored for different sized organizations and really highlighted the immense power and, frankly, accessibility of open source models and tools. Now that you've seen these structured, cost-effective pathways, consider this. Beyond the obvious stuff like chatbots or summarization, what entirely new, maybe surprising applications could you unlock? By leveraging these open source LLMs in your own context, now that you know there are viable, scalable, and affordable paths out there for pretty much every scale of ambition.